once again, I'm Extra Life, and this is the Yamaha Reface CS. It is a compact virtual analog polyphonic synthesizer, has a great layout with one knob per function controls, very easy to program, and it does pretty much everything that I need it to do, with the exception of remembering patches. You can't store and recall sounds that you make on here, so it's a little bit difficult to use sometimes in a live context where you might need to have quick patch changes between songs. You actually have to reprogram everything on the fly. So what I'd like to do is to build a device to solve that problem by adding external patch storage to this synthesizer. Now what I plan to do with this is to add a box more or less about this size, which will have some buttons on it to recall and store the individual presets, and then a MIDI jack on the side so that we can connect to the Reface. And I've collected some parts in this box. We're going to use a standard Arduino Nano. We're going to use some big, bright, colorful buttons so that it's easy to remember which one is which, and we're going to use some of these big old classic MIDI jacks to connect to the synth, as well as some toggle switches to turn the device on or off and select between different banks. Before we start on that though, I think we need to start on the breadboard and see if we can get the Arduino to talk to the Reface CS over MIDI. Hooking up a MIDI output jack is actually one of the easiest things you can do with Arduino because it just connects directly to the serial output jacks. It's a regular serial interface. And all we have to do to get the output is hook up a 220 ohm resistor to our 5 volt power pin. And we're going to connect this red wire here on this side to our 5 volt line through this 220 ohm resistor. We're going to connect the bare wire, copper, which is going to be our shield, to the ground pin of the Arduino. And we're going to connect the other connector to the TX, or serial transmit pin. It's a little bit easier. I'm going to add a potentiometer over here, and we're going to plug it into one of the analog inputs so that we can send control change messages from 0 to 127 over MIDI. And what I'll do is I'll hook up the outer 2 pins to 5 volts and ground, and then the center pin of the potentiometer to one of the ADC inputs here. Got the Reface turned on. Now we hear notes. And so those are being transmitted from the Arduino Nano, regular MIDI messages. So now we just need to reconfigure this to send control change messages. Now I've noticed that the Reface isn't responding to control change messages on the same channel as it's responding to note messages, so I'm going to put this into advanced settings mode and manually set the receive channel for MIDI. So I'm going to hold an A major chord and turn the device on, and so you notice all of the oscillator mode lights are on. So now we can edit the MIDI receive channel by pressing this D sharp here. Choose the receive channel, so I'm just going to put that on MIDI channel Omni, which should be the C right here. In addition to the A major settings mode, there's also pretty much all of these keys here toggle something on or off. And so local control is toggled off by holding the first E key on the keyboard here. So if I turn this on, while I'm holding that key, you can see this light blinks, confirming that we've changed the setting. And now I can turn this knob, and we get MIDI control. So now that we've got this set up, let's work on getting MIDI receive. Getting MIDI out of the Arduino is super easy, just a resistor and a couple of wires. Getting MIDI into the Arduino is substantially more complicated. We need a handful of parts here. We've got a couple of resistors, a diode, and we're also going to need an optocoupler, which is an LED, and a photodiode on the other side. So without any electrical connection, photons get transmitted from one side of this device to the other and transmit the data. And it prevents noise from being built up in MIDI cables. So we're going to grab one of these, put it on the breadboard, and wire up the MIDI jack into it. So the schematic I'm following here is more or less directly from the original MIDI specification published in the 80s. We're going to take this diode, and we are going to bridge it across the anode and cathode of the internal LED. Our 220 ohm resistor goes on the low side of the diode, which in this case is pin 1, and then that connects directly to the jack here, which is the transmit line. Then we're going to grab 5 volts from the Arduino and connect it to the VCC, or voltage supply, of our chip, which in this case is pin 6. Ground from the Arduino over to pin 5, and we're going to connect pin 4 directly to our serial input, so that's RX1 on the Arduino. And then we're going to connect a pull-up resistor from that RX pin to our 5 volt line, so I'll just do that right here. Now we should be able to connect our MIDI cable to this MIDI jack and actually receive some MIDI data to the Arduino. we're listening in over MIDI messages from the Yamaha, and when I play a note on, we should see this LED light up. And it should also light up when we send control change message 74 for the filter cutoff, and turn off when we send a different one. So we can now listen to control change messages as well as note on messages or any other message we like on the Arduino. And then also, again, on the Reface CS, you actually have to turn on MIDI transmit. So again, we enter the special mode by holding this A major chord, and then by holding this first C sharp, then we can choose a MIDI channel to transmit on. So if for some reason it was on off, which was this C, so I just put it on channel 1. Anyway, now that we've done the really frustrating part, it's time to do the fun part, which is coming up with an enclosure and an interface so that we can actually use this thing to store presets and then send them back to the Reface. All right, now that we've got the electronics working, it's time to start thinking about the hardware. And basically what we're going to do is fit this little Arduino into this big box. And we're also going to lay out some of these nice spring action push buttons in here. I think my idea is going to be we're going to have 8 total of these buttons. So 4 across in 2 rows. One of these is going to be an on-off switch, and another one is going to be to switch between banks. We'll probably want an LED to indicate whether it's on or off. And then, of course, we're going to need to fit in some MIDI jacks coming in on the side here, and I'd also like to fit in a battery. And then we'll have the Arduino sitting somewhere in here. But in terms of actually making the connections, it would be kind of a pain to have like 15 or 20 flying wires coming off the Arduino, going to the buttons and the jacks. Plus, we need that little circuit with the optocoupler and the resistors in order to get the MIDI input working. So I think it's actually going to be worth our time to make a little printed circuit board. I've got some blank copper board here, and we'll figure out what size we can make so that it fits into the slots in this little plastic enclosure. And then the Arduino can just stay like this with the header pins and slot into some sockets. So I'm going to get in KiCad and design a quick PCB so that we can make these connections. All right, I've sketched out our circuit in KiCad here, and you can see it's not that complicated. We've got the Arduino Nano here with all of our digital connections. Most of the pins are left floating. We don't need to use any of the analog inputs. We've got a 2-pin connector here for the battery. We're just going to go through one of the switches so that we can turn it on and off. We've got the serial outputs coming out through this optocoupler so that we can connect to the MIDI input and the MIDI output through a resistor here. And then I've just got a bunch of these digital inputs going to a 10-pin header, which is the same as like a Eurorack power cable, so that we can use one connector to make like 10 connections to the PCB and wire up all of the buttons with one ribbon cable. That'll be really nice. And then I went ahead and laid this out on a PCB, and we have just enough space for all the components. And on a single-sided layout that you're etching at home, you want to leave a lot of space between these traces, so I didn't want to run them all super close together. It's simple enough for a one-sided PCB, and then I added a filled zone here, which is connected to the ground net. And that'll just save on PCB etching so that we don't have to eat away all of this copper in the empty areas that we would otherwise not have any copper on at all. I'm going to make a printout of this board so that we can actually get it onto some copper and etch it with ferric chloride. Trying something new today. I'm using some of this PCB transfer paper. In the past, I've had pretty good luck with this like glossy laser printer paper, but it is a little bit tough to get the paper off the backing. Let's put this in the laminator and see if we can get it on the copper. So I got this board etched, and I was starting to put these parts together, and I was really struggling to get some of these parts in, especially this Arduino socket and the 10-pin header. And I started thinking, well, did I mess something up with the drilling? And then I started counting the pins, and I realized the pin pitch is not correct. And sure enough, what happened is I printed out the transfer of this, and my printer software automatically scaled it down so it would fit on the page at 96% size. So this is the wrong size. It's not going to fit any of the parts. So I went ahead and made another one, which is, as you can see, ever so slightly larger. And this one actually is the right size, which means, of course, that it will actually fit the socket that I want to put in those holes. So with that done, we can start putting some parts in here and build up this PCB. Alright, I think I've got this all soldered up. Arduino fits on here. The header connector just barely fits on there. I think it'll work though. We've got our ribbon connector here, which fits on like so, allowing us to make a whole bunch of connections to our buttons. And then I put in some little inline headers here so that we can do jumpers over to the MIDI jacks. I think that's going to make it a little bit easier to debug. And for the power inlet, I also just added a 9-volt battery snap as well as an inline switch so that we can turn this on and off. Now we can hook up a 9-volt battery to the snap, and we should be able to turn the Arduino on without having it plugged into USB. Nice. And we've got these little fins that should be able to guide the position of the PCB in here, so we can slide it in more or less anywhere we want. So I'm going to start marking out some holes for drilling on the other side of this PCB. Then we'll head over to the drill press, put some holes in this, and start putting it together. Alright, I have the PCB put together and the buttons wired up inside the case here. So, as you can see, we've just taken this ribbon cable and split it out to each of the individual buttons, and then we've got a common ground wire that connects all of these so that they can be used in input pull-up mode with the Arduino Nano. So we just take this header connector and pop it onto the Arduino, and now we can actually test the hardware, which is the first thing to do before we start getting into MIDI or anything like that. We just need to make sure all of these buttons and this LED work. If we push any of these buttons, we should see the LED light up, and lo and behold, all of the buttons are working. Now that we've got the buttons confirmed and working, we can plug in these MIDI jacks, which just have these 5-pin headers soldered onto the ends of some wires, and they'll plug into the header sockets like so. This is just kind of my rough and ready connector. I found out recently that the proper term for these like 2, 3, 4, 5-pin board-to-board interconnects are JST connectors, which I think is like Japan something technologies. But they're those actually keyed single-row headers that you can use for joining like a small number of wires, where you're not going to use a big IDC connector, you just want a small keyed header. Those are called mini JST. Anyway, let's plug these in and test our MIDI functionality. Alright, after a little more futzing around, I have MIDI I/O working. I've got the buttons plugged in, and the MIDI comes out over this jumper cable, and we can push the buttons and play the notes. We also have MIDI input working into this thing. You can see that this LED comes on when I play a note here. One oddball thing that's happening, though, is that when we have the MIDI input connected here, we actually get a doubling of the note. So we get a nice clear sounding note, and then when we plug it in, it gets doubled up. There's this sort of this phasing effect. I don't know if you can hear that too clearly, but what I discovered basically is that the MIDI notes are going out to the Arduino and then bouncing back out through the MIDI output into the keyboard, and they're getting played twice every time you play a key. So what I discovered is that the Arduino MIDI library by default has MIDI through enabled or pass through, so that anything that comes into the input goes out the output. So because we're sending in and out to the same device, which is a little bit atypical, we actually need to turn that off in the MIDI library in order to disable that doubling effect. Okay, I think we've got this thing more or less working as it should. We're sending and receiving MIDI, and the Arduino can now remember all of the CC data that it receives over the MIDI port. So if we're playing a patch here, we might have a pad sound on one preset, and then we can push a button to choose another preset that could be totally different. If we want to make some changes to a patch or save a new preset, we simply move the faders that we want to adjust. So maybe we'll change the envelope sound of this lead patch, and then we press and hold the patch that we want to store and hold that button down for 2 seconds until the LED starts blinking, and now that patch is stored in memory. So if we go to another sound and now go back to it, now we have our new envelope control. Each patch just consists of a list of control change values for each of the assigned parameters on the front panel here. And there are 17 in total that are transmitted and received from the front panel. There are a couple other hidden parameters that you can access, like the pitch bend range. You can make this 2 steps or 12 steps. Anyway, for those 17 parameters, of course, we need 17 bytes of data for each preset at a minimum. And the Arduino Nano with the ATmega168P has 512 bytes of E² PROM, or memory that you can write to in real time while the Arduino is running. 512 bytes of memory is enough to store 30 presets if there are 17 parameters. So since we have only 8 buttons, that's more than enough. But we also have this switch, so we can toggle over to a second bank and access an additional 8 presets. So in this mode, we've got presets 1 through 8, if you like. And in this mode, we have presets 9 through 16. Well, I think that came out all right. This little device helped me change patches very quickly. It helped me get to a lot of sounds that I otherwise wouldn't be able to get to quickly, and do things with this keyboard that I would otherwise be reluctant to do. Having a preset, obviously, is a lot more accessible than having to remember every single knob position, especially on a device like this where the sliders are so short and very sensitive to small changes. I will, of course, upload all of the files for this, including the small PCB and the Arduino code that I uploaded on the Arduino to make the MIDI program changes work. If you want to build something like this for yourself, feel free to use that and ask any questions that you have down below. As always, I want to say a huge shout out and thank you to my supporters over on Patreon. It means the world to me to have your support, and it means that I'm able to take the time to make and edit these videos. So thank you very much. And if you're interested in getting a little bit of bonus content as well as early access to all of my new videos, head on over to patreon.com/extralife and become a supporter today. Well, I think that about does it for today. I'm really looking forward to playing with this patch box, loading some more presets into it, and figuring out how I'm going to integrate it with the rest of my live setup. If you've got a similar synthesizer situation, perhaps building a device like this could be a solution that works for you. And as always, thank you very much for watching. I'll see you next time.